Good morning, teacher.
Good morning. Good morning. How's it going?
Good. I sent you the definitions yesterday,
hmm
and I was waiting for your response, but I haven't received anything.
Yep, I'll get to that this morning.
All
hmm
right.
Yeah. I'll get to you this morning. I was not able to get on my uh get the chance to respond to my emails last night like I wanted to. So I most definitely hit that this morning, probably right after this class.
Okay, thank you.
Yeah, no problem, no problem. All right, let's
Good
see. So,
morning.
hey, good morning. All right. Feel like everybody's in. So, good morning, everybody. I hope all is well. Everybody's doing okay. Just checking to see where we're gonna start today. Um, any general questions before we go ahead and get started? Everybody doing all right?
I had a question.
Mm-hmm.
I did see that there's a test on Pearson's. Is
Mm-hmm.
that our actual test or is that a practice test?
No, this is legit. Your actual test. Yep.
Oh,
Yeah.
and do you have a certain amount of time to turn it in? Is it going to be a time test? Like, how does that work?
It's not timed, and that due date is the 8th, August 8th. But it's just one of those things that, the way I'm doing that, whenever I put a due date that says August 8th up there, that just means that you have until August 8th to actually do it. There's no penalty. But what you don't want to do is wait until August 8th to actually do it. You know what I mean? We're going to, like we're in chapter 3 right now, so you don't want it to be sitting out there as we continue to, go and further progress throughout the class. So you want to knock it out as soon as possible.
Okay, thank you.
Yep, not a problem. All right, just checking one thing. 3, 3, 4. Okay, cool. All right, so we can go ahead and get started. Oh, see something in the chat. Yeah, there you go. I just put it in the chat. So send up this weekend. Okay, yep. So just vtucker at tcc.edu. Yep, not a problem at all. Okay, so let's go ahead and get to these notes. So we're starting in 3.3 today. I'll start with black. All right, so let me write a few notes. This red is not for you. I'm just writing a note to myself as to where I'm going. All right, then we're going to IQR. And we're looking at range. All right, so those are the three things in this section. All right, so 3.3 summaries for skewed distributions. A lot of the content in this class is the same as Math 245. They just have it in different order. So that's why I just write notes to myself. All right, so let's go to the median first. All right, so the median. Your median is your middle value. So I always think about the middle when we talk about the median. It's your middle value. So the way we would find our median, first step, and notice I wrote there, don't forget, because a lot of times people forget that first step is you want to list your data values from least to greatest. Then if the number of data values is odd, take the middle value, because if you have an odd number of data values, then you will have a middle value. But then step 3, if the number of data values is even, you're going to take the mean or the average of the 2 middle values. I'll give you a chance to write that down. Scroll up. Of course, just like before, if I scroll up and you still copying something, let me know. Everybody done with step 2? All right. So the data set, let's say we have a data set 1, 2, 3, 4, 5. Notice over here in the blue, that's an odd number of data values. Go purple. Odd number of data values, so that means we do have a middle number. So our median would just be 3. My second data set, I have 1, 2, 3, 4, 5, 6. This time I have an even number of data values. So that means I do not actually have a middle value. So what I would do is take the 2 values that are in the middle, 3 and 4, add them together and divide by 2. And that will be my median. All right, any questions on that? And notice the median separates the data into halves. Let's see that. All right, so here in the orange, just in case they were to ask you in my math lab, it also represents a typical value in a data set. So it separates the data into halves, and it also represents a typical value in the data set. All right, anybody still copying median before we scroll?
Professor, before you continue, do you know when, like, what day you'll post the recordings?
If I get to them tonight, I will, but if not, Friday morning. That's my
Okay,
goal.
thank you.
That's always my goal, to get to it by Friday morning. Yeah.
Awesome, thanks.
Yeah, not a problem. All right. Not a problem, Mr. Echols. It's all good. It's all good. All right, so we good with median? I can scroll to the next thing. That's street. All right, so let's look at No quarter percentiles, no quartiles. All right, next thing you talk about in this section are your quartiles. So your quartiles divide the data set into fourths, or your median divides your data set into halves or into half. Quartiles divide your data set into fourths. So notice we have your minimum, maximum, your smallest value, your largest value, and then in the middle, we have our three quartiles that helps break up the data set. All right. So first thing we'll do in order to be able to find our quartiles, list our data set from least to greatest, or data values from least to greatest. Then we will find quartile 2 first. That's going to be the median of the whole data set. So we just finished talking about medians. That's going to be the middle value of your whole data set. It's going to split your data into half. Then Q1, quartile 1 will be the median of the first half of data. Then quartile 3 will be the median of the second half of data. So basically all you're doing is finding three medians. First one is the median of the whole data set. The second one you find is the median of the first half of data. And the third one you find will be the median of the second half of data. That's last. Yep. All right. Next thing, your interquartile range, IQR. It's going to be Q3 minus Q1. That's the middle 50% of your data set. All right. So we can use this information to check for outliers. Okay. They kind of split this information up. We'll go ahead and talk about it since it's right here. And it makes sense for it all to be together because it all ties in together. This actually comes out of 3.5 for us. But we'll just go ahead and talk about it right here and come back to it. So checking for outliers. Outliers are extreme values in reference to the data set. So you'll be able to create an upper fence by doing Q3 plus 1.5 times the IQR, and then a lower fence, which would be Q1 minus 1.5 times the IQR. So if a data value is greater than the upper fence, then it is an outlier. If the data value is less than the lower fence, then it is an outlier. Because remember, your outlier can be very extreme or very small. So this is a way to put a value or a marker for your outliers. Okay. So let's do a copying. Can I go to the example? Good, good. All right, let me erase some of this stuff. And then we get rolling. Yeah, I can leave it like that. Okay, so let's say we have these data values. I went ahead and wrote them from least to greatest. That is your first step. What we're going to do is find all of our quartiles in a quartile range, determine if we have any outliers, all the good stuff like that. So you list your data values from least to greatest. So I have 18, I said 18, 180, 189, 370, 618, 735, 802, 1185, 1414, 1657. Now notice the way I wrote them. I recognize, and this is how I tend to do these lists. I recognize first that I had 18 data values, so I already wrote them in halves. To me, that helps me organize what's going on. So I wrote the first 9 together, then I wrote the second 9 together. So that's what I mean. I already wrote them in half. So if I had 24 data values, I would write 12, then write the other 12. That's just, to me, that helps. All right. So then I wrote the other 9, like I said. So that's 19, 53, 23, 32, 23, 36, 34, 61, 46, 68, 67, 51, 9908, 10,034, and 21,147. All right. So once again, we have 18 data values all together. The first half, I have 9 data values. The second half, I have 9 data values, but I do not have a middle value. Remember, the first thing you want to find is Q2, which is the mean, the median of the whole data set. Since we have an even number of data values in totality, that means I do not have a legit middle value. So what I'm going to do, let's see, let me go back here. I might as well just go ahead and put these up. So what I'm going to do is take the 2 middle values, 1657 and 1953, add them together and divide by 2, and Q2 is 1805. Okay, so once again, I have your second or your first term that you're going to find is Q2. That is the median of the whole data set. I have 18 data values altogether, which is an even number. That means I do not have a legitimate middle value. So I have to take the 2 middle values, which is 1657, 1953, add them together and divide by 2. And that gives me Q2. All right, any problems with Q2? Q1, now don't forget, my first half of data has an odd number, it's 9. So that means I do have a middle value. So that doesn't call for any calculation. I just pick out the middle value, which is 735. Same thing with the second half of data. I have 9 data values in my second half of data. So 4668 would be my Q3. Any problems? Next thing we do is find IQR in a quarter range.
I'm sorry, can you say why Q1 is 335 again?
Yeah, 735?
Yeah.
Oh, because you have an odd number of data values. We have 9 data values. And so all you do is pick out the middle one.
Okay.
Yeah. So now if it was an even number of data values, then you would have to take the 2 middle values, add them together and divide by 2.
And that's the middle value of the first half?
Yes.
Okay.
Mm-hmm. Yep. So for Q2, you're looking at the whole data set. For Q1, you're just looking at the middle value of the first half of data. For Q3, you're looking at the middle value of the second half of the data.
Okay, thank you. I got it now.
Not a problem. No problem. So everybody good with that before we go to the next thing? Make sure we're clear. Everybody straight. All right. So Q3 minus Q1. That's your interquartile range. You'll be able to use your interquartile range to compare data sets and all of this stuff like that. Well, that's why you would use it. I don't see where they will actually get you guys to do it in the book, but that's why someone would want to know what's the range of the middle 50% of data if you're trying to, compare data sets. All right. So now we can determine our fences. Remember 1.5, the 1.5 is a part of the equation. So it's Q3 plus 1.5 times the IQR. That's how you find your upper fence. So that's 4668 plus 1.5 times 3933. That gives us 10,567.5. So if anything, or any one of our numbers is larger than that number, then it would be considered an outlier. Lower fence, Q1 minus 1.5 times IQR. So it's 735 minus 1.5 times 3933. That gives us negative 5164.5. So if anything is lower than that value, that will be considered an outlier. All right. Any questions before we look at the last step? All right, can I scroll up? All right, so after you establish your fences, you can actually determine if there are any outliers. The answer is yes. That's that 21,147. That's because it is greater than our upper fence. Any problems? Any problems? All right. Any questions on the process or any of the steps before we go to the next thing? Make sure we're good. All right. All right. So you guys can start right here. The last thing in this section is your range. Just the largest data value minus the smallest data value. Yeah, just as simple as that. And so if we have the data set of 1, 2, 3, 4, 5, we want to find a range of data, how much the data is spread, and that'll be 5 minus 1, which is 4. And I guess we can call it, let's say it's the distance. So that's what your range represents, the distance spanned by the entire data set. All right. Any questions? Can I move to the next thing? Make sure we're good. All right. Let me see, where did I put this at? All right, we'll come back here. 3.2. So that was it for 3.3. Let's look at 3.4. All right, so 3.4 is comparing measures of center. All right, so first statements coming out of this section, talking about measures of center. So when you have a symmetric distribution, the mean and median are approximately the same. In a right skewed distribution, the mean tends to be greater than the median. And then in a left skewed distribution, the mean tends to be less than the median. Once again, this red is for me. Just shoot myself a note. All right. Is everybody okay with the green before I go to resistant to outliers? All right. Okay, so a summary of data is said to be resistant if outliers to the data set do not affect it. So you're talking about being resistant to outliers. It is considered resistant to outliers if the outliers do not affect it. And I'll show you what I mean about that. By that, in a second, give you a chance to write it down. Okay, so first data set, we've done this up one already, 1, 2, 3, 4, 5. The mean and the median are 3, when we do our calculations. So that's not a surprise to you. Like I said, we've already done that one. But now in the blue, let's say if I change that 5 to 500. So I have 1, 2, 3, 4, 500. So that 500 is going to be considered an outlier. It is very extreme to the rest of the data in comparison to the rest of the data. But if I were to use the data, all of those data values, if I want to find the mean, that's 1, 2, 3, 4, 500. Add those together, divide by 5, I have 102. Well, remember the mean initially was 3, but once I, put an outlier in there, the mean changed dramatically, right? But if I look at the median is always going to be the middle number, and that was not affected. And so the median is 3. So notice how the median didn't change, even though an outlier was placed in our data set. So this means the median is resistant to outliers. It's not affected by the size of the outliers. Your median is affected by positioning and how many data values you have, but it's not affected by the size of an outlier. Okay, let me write this in here. Let me say it like it is. All right, so hopefully I didn't run that all together. So it is a good choice for a measure of the center if the data contain outliers. While you guys are finishing that, let me check out something real quick. Oh, okay, gotcha. All right. I think there was one other thing I need to write. Everybody good with this? I can go to the next page. Everybody good? All right. All right. So when comparing groups, if any one group is strongly skewed or has outliers, it is usually best to compare the medians and IQR for all groups. All right. Everybody good?
Hold up.
All right.
Okay, I'm done.
All right. Sounds good. Thank you. All right, so last section for today and last section of chapter 3, using box plots for displaying summaries. So I know in here we're doing box plots. Should be doing 5-number summary. Yep, that's it. All right, everybody got the title before we move off this page? Everybody good? All right. All right, so we got the 5-number summary. That's going to be your minimum value, Q1, Q2, Q3, and your maximum value. All right. Everybody good? So your box plots is going to be a graphical tool used to compare groups of data. Consists of a box with lines that extend to the minimum and maximum values that are not outliers. So we'll see exactly what that means in a second. All right, so these lines are called whiskers. Outliers are normally represented by asterisks. Looking at you guys' book, I think I just see dots. But either way, there will be just dots sitting on the outside. So, you know. You guys wouldn't be drawing them anyway. You would actually, see the drawing in my math lab. So, yeah. All right, so there's a generic way of looking at a box plot. You have your minimum value, maximum value on the outsides, Q1, Q2, Q3 as a part of your box makeup, and then our outliers sitting, to the outside. However many outliers you have, of course, if you have any at all. All right, are we okay to go to the example? Okay, so let's look at an example, finding the 5-number summary and the box plot. So notice what the directions just say, give the 5-number summary and to sketch the box plot. Notice in the red, it said the data set is not always written from least to greatest. Make sure this is the case before you move forward. Remember, I mentioned that before in the last section. Always want to make sure your data set is set up from least to greatest before you start finding Q1, Q2, Q3. Make sure everybody's written it down before I scroll all the way up. All right, so I set this up similar to the way I did the last time we were looking for quartiles. Wrote my data set from least to greatest. Now I erase all this stuff. All right, so I have 21 data values all together. All right, so I already know there is a middle value, and I wrote my data set in that way. They would just give you all of the numbers all together. But remember, I like to split up my data set as I'm writing them out from least to greatest, first half and second half. Well, if I have 21 data values, then I already know that I will have a middle value. So why not go ahead and set up my stuff so that my middle value is right there in the middle, and then have my other data set. So this is just how I do it. You don't have to do it this way. Do whatever you like. As long as you get the right answer, then that's fine. But when I rewrote my data set from least to greatest, I had 21 data values. So I know that I have 10 data values in my first half of data, 10 data values in my second half of data, and I have a middle value. So that's how I wrote it. Of course, they will not give you the data set in that way. That will be your choice to do it or set it up that way. But I find it easiest to go ahead and split up my data into halves. And if I have a middle value, go ahead and set that data value in the middle and go from there. So that's what I did here. All right. So first move is to find, I'm going to put my circles back. Missing one. Yeah. So the first step is to find Q2. But like I said, if you wrote your data set the way I wrote it, you already picked out the middle or found the middle value, which is 30.95. Remember, if you have an odd number of data values, then there is a middle value with no calculation. And that is 30.95 for us. Now Q1 is going to be the median or middle value of the first half of data. Now there are 10 data values in the first half of data, so there is no legitimate middle value. So you have to take the two middle values, which is 25.83, 26.28, add them together and divide by 2, and that would be 26.06. All right, questions on Q1? All right, Q2, very similarly to Q1, have 10 data values. So there is no legitimate middle value. So you take 37.05, 37.43, add them together, divide by 2, that'll be 37.24. Any questions, any questions? All right, can we go to step 5? All right, so now we'll use or find our IQR. That's going to be Q3 minus Q1. So 37.24 minus 26.06, 11.18. All right, so then we can find or establish our fences. Your book calls them limits. Call it, so if in my math lab they ask you about limits, talking about right limit and left limit. I think this word, yep. Still the same thing, but I guess I could put left limit first on top since left limit is the lower fence. All right. But like I said, it's still the same calculations, still the same numbers. So that'll be 26.06 minus 1.5 times 11.18. That's 9.29. And then for our upper fence, 37.24 plus 1.5 times 11.18, which would be 54.01. Any problems? So just a reminder of what our fences mean to us. If a value is less than the lower fence or greater than the upper fence, it is an outlier. All right. Everybody good? So determine your outliers. 54.63 is considered an outlier because it is greater than the upper fence. So now we have enough information to find our, or sketch our box plot and write out our 5-number summary. All right, so our 5-number summary, take the minimum, which is 19.95, that's the smallest value, then Q1, Q2, then Q3, so it's 26.06, 30.95, 37.24, and then our maximum value, 54.63. So notice when you talk about your 5-number summary, that has nothing to do with whether a value is an outlier or not. You just would, use whatever your minimum value and maximum values are. So that has nothing to do with outliers. Just throwing that out there. And our box plot will look like this. So 19.95 is our minimum value, our smallest value, and it is not an outlier. So our whiskers would extend to that value. Q1, Q2, Q3 will be our lines of our box. And then notice right here, that's 49.17 is what our whisker would extend to on the right, because that's the maximum value or the largest value that is not an outlier. And then we have an outlier of 54.63. I ran those a little bit together. That's okay. Yeah. All right, questions on anything? Excuse me. All right, so that is it for chapter 3. Any questions? Everybody good? Everybody straight? Okay. So as always, make sure you try this stuff out. You see, I always try to leave room for questions. So you can always have questions, ask your questions during class time. If not, always shoot me that email and we can make it happen on that front or in that fashion as well. So try the stuff out. Notice at this point, you guys are held responsible for chapter 1, 2, and 3. We're done with that material. If you look in Math Lab, you should see all of your homework assignments for 1, 2, and 3, and then that first test from chapter 1 and 2. Any questions before we close out today? Make sure we're good. I see something in the chat and make sure. Yes, sir, Mr. Eccles. All right. Yeah, you just shoot them to me an email. That's fine. Yeah, that's fine. All right. So if you guys are good, I am good. I will see you on next class. Okay. No, there's not. No, you just shoot them to me an email if you're talking about the definitions. Yep, just vtucker@tcc.edu. Yep, you have a good one as well. You guys have a great weekend. Mr. Eccles, you said your math lab code does not work. Are you talking about what you purchased from Barnes and Nobles, or when you say math lab code? Just want to make sure.
Have a good day. And also, you said this will be posted tomorrow, Professor?
Yes, I'm gonna try to shoot that to you guys tomorrow.
Okay. Thank you. Have a
Yep.
good day.
You do the same. Thanks. So you may have to. Some people had to call, just call customer service, or if they say email, whichever way they got you guys set up. When you go to the web page, not Barnes and Noble, but Pearson's web page, if you go to customer support, do that contact us, let them know, and then they'll change it for you. See, there was somebody right there. Yes, thank you. I appreciate it. So, yeah, she said that if you go to Pearson Help, they'll change it for you. All right. Thank you for that. All right, so Mr. Eccles, let me know if you have any problems outside of that with your code. But you should be able to hit Pearson Help, and they should be able to help you out on that front. All right. Anything else before we close? Everybody good? All right, sounds good. You guys take care. See you on next week.